an electrically neutral sphere made of copper. Okay, so you're talking about copper and the mass of copper. We are giving that. This is what we are giving. Okay, we are giving that the mass of copper is 4.8 grams. Okay, contains equal amount of positive and negative charges. So it means that the positive charge and the negative charge are equal. Okay, but however, the signs will be different. Okay, so now they say what is the total charge in the sphere if it is entirely made of copper? So it means that we have a sphere that is made of copper, okay, and it contains equal amount of positive and negative charges. Okay. Now, how do we solve this question? How do you get to that charge? Now, normally, I would need the molar mass. I would need the molar mass of copper. That would be 63.5 gram per mole. Okay, this is the atomic mass. Okay, then I would need the number of. Okay, I'll need the atomic number. Yeah, I'll need the atomic number of copper. That will be 29. Okay, that'll be 29. You can also call it proton number. Okay. Now, this actually means that the number of protons is 29. Again, it means that the number of protons is 29, and it also implies that the number of electrons is also 29. Okay. Then I would need to look for the number of moles. Okay. I need to look for the number of moles. What is the number of moles? Number of moles of copper should be mass over molar mass. Okay. That will be the mass is 4.8 over 63.5. That would give us um, 4.8 divided by 63.5. That gives us 0.0756. Okay, so this is the number of moles of copper. Okay, now I would also need to look for the number of atoms. Okay, yeah, I'll look at the number of atoms of copper. Yes, so what becomes the number of atoms of copper? Number of atoms. If I can get the number of atoms, I can get the number of protons. Okay. Number of atoms is equal to number of moles multiplied by Avogadro's number. Okay. So let's get number of atoms. So I'll be having number of atoms to be 0.75756 times Avogadro's number is 6.02 times 10 raised to the power 23. Okay. So that will give us times 6.02 times 10 to the power of 23. That will give us 4.55 times 10 raised to the power 22. Okay. Now this is the number of atoms of the copper. So now let's look for the number of protons. Okay. Because the number of protons will equal the number of electrons. Okay. So remember the number of protons is equal to the number of electrons here because what we have is a neutral atom. All right. Now the number of protons here should be proton number multiplied by number of atoms. To get the number of protons, you multiply the proton number and the number of atoms. So we'll have proton number is actually 29. So it becomes number of atoms becomes 4.55 times 10 raised to the power 22 multiplied by 29. That would give us times 29. That will give us 1.319 times 10 raised to the power 24 protons. Okay, so we have 1.319 times 10 raised to 4 protons. This is the number of protons that we have. Now, since the number of protons equals the number of electrons here, we can say that the charge in the system, total charge in the system here becomes number of protons multiplied by E. Remember, this could become number of electrons too. Okay, so it becomes 1.319 times 10 raised to the power 24 times 1.6 times 10 raised to the power minus 19. So if I multiply it by 1.6 times 10 to the power of minus 19, I'm going to be having 2 11,145.57. Okay, this is the number of charge that we have in coulombs. However, remember that it has equal amount of positive and negative charges. Okay, so since we have equal amount of positive and negative charges in the system, what does that tell us? It tells us that Q is positive 211145.57 coulombs, and Q is also negative 21145.57. Okay, so what becomes the total charge in system? Where the question says, what is the total charge in the sphere? So how do I get total charge in the sphere? Total charge in the sphere now, total charge in the sphere becomes negative this plus this. That gives us 0. Okay, so it means that our answer in the first question, the total charge in the sphere is 0, because when I looked for the charge, each of those charge contains each of those spheres. Okay, so the sphere contains this charge. Okay, this is charge it contains. But the question says that it contains equal amount of positive and negative charges. So it means that this guy is equal in positive and in negative. So the total charge in the system becomes sum total of the charges, which is negative, positive this, negative this. They are the same, so it gives us 0. Okay, so total charge is 0 in the system. Now going to the next question. The next question says, if the positive and negative charge are placed in two separate, so it means that I now decide to place one of the charges and the other one, okay, in two separate bundles separated by a distance of 80 meters. Okay, and they're asking me what is going to be the force of attraction between them. It's going to be an attractive force. Why? Because this is positive, this is negative. They're going to attract their own like charges. Okay. Now, what becomes the force? The force becomes, use our formula, kq squared over r squared. Okay. Now remember that the system is in a vacuum. The system is in a vacuum. So let's say k is 9 times 10 raised by 9 multiplied by q. I found q to be 2,115.5.57 squared divided by r is 80, so it becomes 80 squared. Okay, we are using our calculator now. We're going to have 9 times 10 raised by 9 times 211,145.57. Okay, come down, we have 80 squared. Okay, so we have the force becomes 6.269 times 10 raised to power 16 newtons, and this force is going to be attractive. Okay, it's going to be attractive. Thank you.